Let us solve some more problems on finding the Z transform of the signals using appropriate properties. Here I have taken the three problems. First problem is x of n is equal to alpha to the power of n into sine of omega naught n into u of n. Second problem is 1 by 2 whole to the power of n into convolved with the 1 by 3 whole to the power of n into u of n. Third problem is x of n is equal to n into 1 by 2 whole to the power of n, that is linearly convolved with the same signal 1 by 2 whole to the power of n into u of n. Okay. In these problems, we need to use the scaling in the Z domain property, convolution property, and differentiation in Z domain property. Okay, let us take the first problem. X of n is equal to alpha to the power of n, that is sine of omega naught into n into u of n. Okay. In this problem, let us take this part of the signal as x1 of n. Okay. Now let us take let x1 of n is equal to sine of omega naught n, sine of omega naught n into u of n. Then what is x of n? X of n is equal to alpha to the power of n into x1 of n. Okay. Now this you can write its Z transformation using scaling in the Z domain property. The scaling in the Z domain property says that a to the power of n into x of n, its Z transformation is x of z by a. Similarly here, this is x of z is equal to x1 of, that is z by alpha. To get x of z, first we should get the x1 of z. In x1 of z, we should replace z by alpha. Okay, what is x1 of n here? Sine of omega naught n into u of n. That is x1 of z is equal to summation of n tends from 0 to infinity. Because of u of n, range is 0 to infinity. That is sine of omega naught into n into u of n value is 1 into z to the power of minus n. I told you, when you have trigonometric functions, express them in terms of exponential signals. That is summation of n tends from 0 to infinity e to the power of j omega naught n minus e to the power of minus j omega naught n divided by 2j into z to the power of minus n. Is x1 of z is equal to 1 by 2j, you take it outside the summation, then you can write this one has summation of n tends from 0 to infinity e to the power of j omega naught into n into z to the power of minus n. We can combine these two. We can write e to the power of j omega naught into z to the power of minus 1 to whole to the power of n minus summation of n tends from 0 to infinity e to the power of minus j omega naught into z to the power of minus 1 whole to the power of n. Okay. Now this is x1 of z is equal to, you can write this is 1 by 2z. This can be written as 1 divided by 1 minus e to the power of j omega naught into z inverse minus, this is 1 divided by 1 minus e to the power of minus j omega naught z inverse. Okay. Next, let us take its LCM. That is x1 of z equals to 1 by 2j, keep it as it is, and you take its LCM, that is 1 minus e to the power of j omega naught into z inverse into 1 minus e to the power of minus j omega naught into z inverse. That is 1 minus e to the power of minus j omega naught z inverse minus 1 minus of minus will become plus e to the power of j omega naught into z inverse. Okay, 1 and minus 1 is get cancelled. It is in the numerator, in these two terms z inverse is common. You get e to the power of j omega naught minus e to the power of minus j omega naught. Let us adjust this 2j here. Okay, whole divided by, we'll multiply these two, will get 1 minus e to the power of minus j omega naught z inverse minus e to the power of j omega naught z inverse plus, it will get e to the power of minus, because e to the power of j omega naught into z inverse into e to the power of minus j omega naught z inverse will become z to the power of minus 2. This part will become, that is sine of omega naught, that is z inverse, it is nothing but sine of omega naught whole divided by 1 minus, in these two terms minus z inverse is common, you'll get e to the power of j omega naught plus e to the power of minus j omega naught plus z to the power of minus 2. This is, you can express that in terms of cos function. So adjust 2 and 2 here, you'll get, that is x1 of z is equal to, it is z inverse sine of omega naught whole divided by 1 minus 2z inverse, you can write this is cos omega naught plus z to the power of minus 2. Okay, this is the x1 of z. Now to get x of z, okay, you know that x of z is equal to x1 of z by alpha, that is x of z is equal to, wherever z is there, that you replace it by z by alpha, you will get, that is z by alpha whole to the power of minus 1 into sine of omega naught whole divided by 1 minus 2 into z by alpha whole to the power of minus 1 into cos omega naught plus z by alpha whole to the power of minus 2. You can write this one as x of z is equal to z to the power of minus 1 divided by alpha to the power of minus 1 can be written as alpha into z inverse into sine of omega naught whole divided by 1 plus 2 into this is 2 alpha z to the power of minus 1 into cos omega naught plus this will become alpha square into z to the power of minus 2. This completes the first problem. Okay. Let us take the second problem. Second problem, that is x of n is equal to, we have 1 by 2 whole to the power of n into u of n, that is linearly convolved with 1 by 3 whole to the power of n into u of n. Okay. In this problem, you know that is convolution property, that is convolution of two sequences in the time domain is equivalent to multiplications of their z transforms in the z domain. Okay, let us take this one has an x1 of n and this one has an, that is x2 of n. Then we can write this as x of n is equal to x1 of n, that is linearly convolved with the x2 of n. You will get, that is its z transformation is x of z is equal to x1 of z into x2 of z. Okay. Now, what is x1 of n here? That is x1 of n is equal to 1 by 2 whole to the power of n into u of n. Its z transformation is x1 of z is equal to summation of n tends from 0 to infinity 1 by 2 whole to the power of n into z to the power of minus n, that is summation of n tends from 0 to infinity 1 by 2 z inverse its whole to the power of n. Then I'll get x1 of z is equal to 1 divided by 1 minus 1 by 2 z inverse. Similarly, x2 of z is equal to summation of n tends from 0 to infinity 1 by 3 whole to the power of n. U of n value is 1 into z to the power of minus n, that is summation of n tends from 0 to infinity 1 by 3 z inverse whole to the power of n. We'll get x2 of z is equal to 1 divided by 1 minus 1 by 3 z inverse. Here the condition is 1 by 2 z inverse is less than 1. Here the condition is 1 by 3 z inverse is less than 1. Finally, x of z is equal to x1 of z into x2 of z, that is 1 divided by, you get 1 minus 1 by 2 z inverse into 1 minus 1 by 3 z inverse, where ROC is z is greater than 1 by 2, because here z is greater than 1 by 2, here z is greater than 1 by 3, that is take the highest number, that is 1 by 2, that is greater than 1 by 3. This is the z transformation of this signal. That's the second problem. Okay. Now third problem, that is x of n is equal to, how that is, x of n is equal to n into 1 by 2 whole to the power of n into u of n, that is linearly convolved with the same signal 1 by 2 whole to the power of n into u of n. Okay, now let us take this part of the signal as, that is, x1 of n. Okay, then we'll get x of n is equal to n into x1 of n. Okay, then what is its z transformation? Using differentiation in z domain property, we can write this one as a minus z differentiation of x1 of z with respect to dz. Okay, now first we should find out what is x1 of z. That is x1 of n is equal to, we have 1 by 2 whole to the power of n into u of n, that is linearly convolved with 1 by 2 whole to the power of n into u of n. Okay, here we should use the convolution property. That is, this is one signal, this is another signal. We'll take this as an x2 of n. Since both the signals are same, we can take this also as an x2 of n. Then we can write x1 of n is equal to, that is x1 of n, that is linearly convolved with the x2 of n itself. Then we can write, that is using using convolution property, x1 of z is equal to x2 of z into x2 of z. Okay, what is x2 of z here? That is x2 of z is equal to summation of n tends from 0 to infinity x2 of n into z to the power of minus n. That is summation of n tends from 0 to infinity x2 of n is 1 by 2 whole to the power of n into u of n. U of n value is 1 into z to the power of minus n. That is summation of n tends from 0 to infinity 1 by 2 z inverse its whole to the power of n. This is the x2 of z. Then x2 of z is equal to 1 divided by 1 minus 1 divided by 1 minus 1 by 2 z inverse. Okay, now what is x1 of z now? X1 of z is equal to 1 divided by 1 minus 1 by 2 z inverse into the same signal, that is 1 divided by 1 minus 1 by 2 z inverse. That is x1 of z is equal to, we can write this one as in z divided by z minus 1 by 2, because we need to express this in terms of positive power of z to differentiate that this signal, that is z divided by z minus 1 by 2. You get that is x1 of z is equal to z square divided by z minus 1 by 2 its whole square. Okay, now what is x of z here? That is x of z is equal to, how x of z is equal to minus z differentiation of x1 of z, that is minus z differentiation of, that is z square divided by z minus 1 by 2 whole square. Is x of z is equal to minus z differentiation of z square divided by z minus 1 by 2 its whole square. That is x of z is equal to minus z. Let us differentiate this. Okay, denominator whole square, z minus 1 by 2 whole square, it will become whole to the power of 4, denominator into differentiation of numerator, that is 2z minus numerator differentiation of denominators, that is 2 into z minus 1 by 2 into 1. Okay, Next, x of z equals to, you have that is minus z, we'll keep it as it is. In these two terms, z minus 1 by 2 is common. Z minus 1 by 2 will take it common. You'll get that is z minus 1 by 2 into 2z minus that is 2z square whole divided by z minus 1 by 2 its whole to the power of 4. This term is get cancelled and you get 3 here. That is x of z is equal to minus z. You get that is 2z square minus z, multiply this term and this term, minus 2z square in the numerator divided by z minus 1 by 2 its whole to the power of 3. And this term and this term is get cancelled. It will become x of z is equal to minus z into minus z, it will become z square divided by z minus 1 by 2 its whole to the power of 3. This is the final answer. Okay. This completes the three problems. Thank you.